So today we're going to learn about arc measures. Okay, so central angles is an angle whose vertex is the center of a circle. An arc, it's a portion of a circle that defines by two endpoints. Okay, your endpoints are your letters. So A, B. Okay, that arc AB is right here, this red line right here, and that it could be your arc. Now there's different types of arcs you can have. You can have a minor arc, a major arc, or a semicircle. Okay, a minor arc is part of your circle measuring less than 180 degrees. A major arc is part of your circle measuring between 180 and 360. So originally I was talking about A to B. Well, you can read A to B this way, that's a minor arc. You can also read A to B this way, which is a major arc. You also have semicircle. Okay, semicircle, there's another name for that. It's like half of our circle. So a semicircle is an arc with endpoints that are the endpoints of your diameter. So just say I continued my radius and made a whole diameter here. A to D is a semicircle. Okay, the degrees of that would be half of a circle, so it's 180 degrees. All right, so right here, it's measuring arcs. All right, measuring your major arc and a minor arc, going about it, you know that the total degrees of a circle is 360. So you're going to use that to help you put your arcs together. So example 1, which I'm going to do with you guys. So it says find the measure of each arc of circle P. This is a T. Where RT is your diameter. So this is my diameter. So it says RS. R to S. Okay, it goes based off of this. So R to S arc is 110. Follow what it says. Okay, want to go back to this real quick. You can read R to S this way as well. It doesn't specify what you'd like to do. Normally when it's only 2 letters, I try to go for the smallest route, but you can go this way as well. And you would do 360 minus 110. RTS. R, you have to follow that in order. Has to go to T, which then goes to S. Okay, so that's everything but my 110. That's taking this RS the other way that we were just talking about. Okay, R, T to S. You would do, there's 360 degrees minus the 110 that we know, okay? And that equals 250 degrees. All right, and let's do the last one here. It's RST. So RS to T. So that's my diameter going straight across. That means it's half of my circle. So half of 360 degrees is 180 degrees. Something that I didn't tell us to do on all of these examples, which is something we need to get used to, is naming whether it is a major arc or a minor arc or a semicircle. It's very, very important that we know the difference because it is something that you will be asked. So 110 is a minor arc. It is less than 180 degrees. 250, it's a major arc. It is between 180 and 360. If it is 180, exactly, that is a semicircle. All right, let's look at the next part of our notes. All right, so sum of central angles. So what they're basically saying is all of our angles are going to equal 360 degrees. Okay, you guys are going to try example 2. It's the same concept we just did on example 1. I would like you to go through and put your answers for all of what this says. Okay, you can put, I know in my notes I put a different answer if you went a different way with it. Example A, you can only go one other way with that example. And I did write that down in my notes. So you can check that out. All right, in example 3, I have full capability that an understanding that you guys can accomplish this. I just want to show you one thing since these are percents. Those are not degrees. So you have to figure out how many degrees it actually is. So it says refer to the circle and then find each measure. So if I want to go from C to D, okay, so I want to take this, it's 18%. So what you need to know is 18% of our total degrees of 360. So you need to do 18% is 0.18. You need to multiply that by the total 360 degrees. Okay, when you do that, you get 64.8 degrees, which is a minor arc. And that's your answer. So you're going to do the same thing for B, C, and D. All right, so congruent circles. We actually talked about congruent circles yesterday in notes. It says if they have the same radius, okay, or radii. Congruent arcs is a little bit different. It says when you have the same measure and they are arcs of the same circle or congruent circles. So that's why I re-brought up what congruent circles are. So it says in the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So what this basically says, they're saying if angle 1 is congruent to angle 2, FG is congruent to JH, the arcs. Okay, vice versa. If this arc is congruent to this arc, then this angle is congruent to that angle. Okay, arc length. Arc length is the distance between the endpoints along an arc measuring in linear units. Okay, there's a formula that you have to follow for this. This is something a lot of my students typically forget, and you shouldn't. The ratio of the length of an arc to the circumference of the circle is equal to the ratio of the degree measure of the arc to 360. All right, so what it's saying is the length of my arc is equal to the degrees over 360 times 2 pi r times my circumference. We will be using this in an example coming up. All right, adjacent arcs are arcs and circles that have exactly 1 point in common. Okay, and when you have that 1 point in common, you can do your arc addition postulate. So it's the measure of an arc formed by two adjacent angles is the sum of the measure of your two arcs together. All right. So in 4, it says find each measure in circle F. So I'm going to do two of these with you. So A, he wants us to find the measure of AED. A, E to D. So these are adjacent. What it said is if they're adjacent, you can just take their two measures together, and that is going to be your arc. Okay, so AED is going to be 63 plus 90, which is 153 degrees, which is a minor arc. All right, I'm going to do one more with you. A, D, B. A to D all the way to B. Okay, a few things you can utilize here. All right, so going across, these are exactly the same, makes a perfect X. You can think of these as vertical angles. Okay, so if that's 63, this is also 63. Okay, so now going across here, they're not the same because it's broken up over here. Okay, so just know that you can utilize that. So A to D to B. So something that I like to look at is A to C, which we have to take, is 180 degrees. And then we just need the 63 more. Okay, so what I did is I did 180 plus 63, and that's 243, which is a major angle. All right, I would like you guys to do C and D. All right, example 5. This is finding the length of the arc. Okay, this is that formula that we were talking about right before. Okay, where the length, I'm going to write it out, equals the degrees over 360 times 2 pi r. All right, so we're going to just fill it into this formula. If I want to find the length of x to y, z to y, if I want to find the arc length of z to y, I have to plug it in here. Well, they tell me it's 75 degrees. So we're going to plug that in. The length is going to equal 75 degrees over 360 times 2 times pi times my radius, that is 4. Now I'm going to just plug this into a calculator. Okay, 75 divided by 360, it equals times by 2 times by pi times by 4, and I got 5.24 inches as my final answer. I'm going to have you guys set up B. One thing to remember is they gave us the diameter in this problem, so you need to come up with what your radius is, or just use pi diameter. All right, let's look at 6. All right, what 6 is asking us to do is to determine whether our arcs are congruent or not. And you have to explain your answer. Okay, so just to reiterate, if arcs are congruent, you have to go back to your definition where it said about congruent arcs. Okay, congruent arcs is if they have the same measure. And they must be in the same circle. So it's same measure and then the arcs are in the same circle, or you have to have congruent circles. Okay, so looking at these, I want you to think about it obviously a little bit. I don't want to just give you guys the answers, but looking at this, do they have the same measure and are they in the same circle? Okay, do they have the same measure, or in the end, are they in the same circle? Okay. This one, there's 2 different circles here, so you have to follow when they're in 2 different circles, they have to be congruent circles. Are those congruent circles or not? Check your answers, make sure that you got these correct. This is a very important material here. All right, have a good day, guys.